want to introduce our next speaker. Very exciting to introduce Emily Fairfax. Emily Fairfax is an assistant professor of environmental science and resource management at California State University, Channel Islands. Dr. Fairfax double majored in chemistry and physics as an undergraduate at Carleton College, then went on to earn a PhD in Geological Sciences from the University of Colorado Boulder. She uses a combination of remote sensing and fieldwork to understand how beaver activity can create drought and fire-resistant patches in the landscape under a changing climate. So if you can give Emily Fairfax, Dr. Emily Fairfax, a round of applause to come on stage too. We are so grateful to have you here.
All right, so the title of my talk today is Smokey the Beaver. And I'm going to be talking to you about how beavers can create these fire-resistant patches even during megafires? Question mark? That's what I'm going to be showing you today. So let's take a step back. Beavers and wildfire. You might not always think about these things together yet. Beavers, important ecosystem engineer, but wildfire is a huge process. Wildfire is something that affects us at a continental scale. And so how exactly are beavers really out there fighting wildfires? We know that they're nature's engineers, and hopefully by the end of this talk, I will have convinced you that they are also our firefighters. Unfortunately, a lot of the streams throughout this continent, and honestly around the world, are pretty degraded. They're simple, they're incised, they're single channels, they're nothing more than a conveyor belt for water, and the ecosystem around them is tiny. But that doesn't stop beavers. When beavers move in, they build a dam. They start to make that their home. They start to slow down the water. And as they do that, that water can seep out into the soil. It can start to affect the ecosystem around it. It can start to provide more water to plants throughout the landscape, not just in the immediate vicinity of the river. And busy as a beaver is a phrase for a reason. It's not just a joke. Beavers keep working. They expand their dams. They make them longer. They make them stronger. They make them taller. And as they're doing that, they continue to slow down that water even more. They continue to expand that riparian or that creekside ecosystem so that it's broader and wider. And this creates more habitat for the beavers, which they love. And I don't know, let's see a show of hands. How many of you have actually seen a beaver on land? This is probably the only audience where I'll actually get hands up. So kind of a lot. So I don't really need to belabor the point too much that they're very awkward. Like, this is a round mammal, 40 up to 100 pounds, huge paddle tail, little web back feet, tiny little grabby hands. Like, that's not an animal meant for the land. It's not a terrestrial animal. And they know that. Evolution has taught them that over millions of years. When beavers are out on the landscape, they're very vulnerable to predators, which is why they don't even stop when they built their dam and they made that pond. They go and they dig these canals out from the pond into the landscape. And these are like little water highways for them. They can jump into them and swim away from predators. They can chew down a tree and then float it back to their pond to build with instead of trying to hulk it over land. Like, they're big, but they're not that big. And so beavers are doing all of this to create a home for themselves and to make it safe for them. But as they do that, they have an enormous impact on the landscape around them. If you were to walk up to a beaver pond in the field, you might see something like this. You've got the beaver's dam, you've got its lodge, you've got those little beavers out in the landscape looking like big chicken nuggets, you've got the one in the water looking very safe and agile, and that's great. And even seeing this, I mean, most of us could admit, yeah, they changed the landscape in a big way, but in a big way that's big enough to stop wildfires, to really interact with this huge and destructive process that us as people have not gotten a hand on? Well, beavers don't just stop with one dam. They build many dams. They do not have a single home pond. They will have their home pond and then secondary dams all around it. They are completely changing the watershed. And they're doing this truly at a landscape scale. Now, if you're like me and you look at satellite images of beaver ponds all day, every day, you know exactly what you're looking at, and you're like, man, that's a great image. And if you don't, that's okay, because I've highlighted some of the key features for you. So in yellow are all of the beaver dams that I can see from this satellite image. Highlighted in blue are the beavers' canals. These are those little water highways they're digging out throughout the floodplain, reconnecting it to the aquatic system. And then circled in pink is the beaver's lodge, and there's just one lodge. There's just one family of beavers here. That is one family of beavers that have created and maintained all of this complexity in the landscape. And we don't have just one family of beavers in North America. We have a lot. We have 10 to 15 to 20, maybe even 30 million beavers. So there's a lot of them out there doing this work at the landscape scale. And when you think about it in that way, then you start to think, maybe they can actually affect wildfires. Because all of this complexity that they're creating that we can see from above, it really affects how the water is moving also beneath the surface. So if we compare a stream without beavers to a stream with beavers, as long as we're in a rainy period when we have that infiltrating precipitation, it doesn't really matter where the beavers are. We are watering the plants from above. Sure, the stream is going to impact the groundwater system a little bit different than the beaver pond will, but honestly, it's being watered, so we don't care. Well, it's not often raining in a lot of the United States anymore. We are so often in periods of drought. And as soon as we enter drought conditions, as soon as we take away that rain that seeps into the soil, that's where the beavers really shine. Because while the stream can have this little narrow effect on ground and soil water around it, the beaver pond has a huge effect. The pond itself is storing an enormous volume of water which is slowly seeping out into the soil. But all of these little canals, they are effectively pinning the groundwater to the surface. They are keeping that soil full of water, so it's like an underground irrigation system. And all of the plants, they can stay green as long as they can reach soil water. In the beaver complex, there's plenty of soil water to go around, but where we don't have the beavers, where we have these degraded streams, there's not. And if there's one careless match, that'll start a wildfire, and the fastest thing that's gonna burn is the driest vegetation. And where we don't have those beavers, there's a lot of dry vegetation. What was once a booming ecosystem during the rainy period becomes this incredible fire hazard. But in the beaver ponds, that doesn't happen because they're staying green, they're staying wet. You don't go out and try to start a campfire with the wettest leaves you can find. If you do, you're not getting invited on the next camping trip because it's a horrible idea. They don't burn. And it's the same thing here. It's just too wet to burn. And this isn't even just a conceptual model. This is something that we've seen. We've actually seen this in these now pretty famous photographs from my colleague, Dr. Joe Wheaton at Utah State University. In the Sharps Fire up in Idaho, he was fortunate enough to take these photos of streams without beavers and streams with beavers. And the difference between them is honestly pretty incredible. So without the beavers, we have the fire on the hill slopes, which is to be expected. They are not particularly connected to the rivers, they're not super fire resistant. But what's concerning is that the fire burned right down into the floodplain, and it burned right down through the river bottom here. And in doing so, it completely destroyed large swaths of this riparian ecosystem. And that's not good fire. There is a lot of good fire that we need in the West, especially, but that was not good fire. However, where we had beavers, that's not what we saw. Where we had beavers, the fire still burned the hill slopes. Beavers are not doing too much work up there. But as soon as we're down into the floodplain, it stayed green. It was like this great big oasis. And when you zoom in, you can see even more clearly. You have these beaver dams, the primaries and the secondaries. You have all of these canals which are reflecting that sunlight back up at the drone. You have all of this hydrologic complexity which is watering the vegetation to the point where even when you have a pretty strong wildfire on either side, it's not burning. And so this is great, and I'm seeing this, and I'm thinking about this, and I'm making a felt stop motion video about this. And I wanted to know, does this actually happen everywhere? Or was this just something that happened once or twice? And to answer that question, I very first dug into this by looking at 5 different fires in 5 different states, and what they all had in common was they have a lot of beavers within the fire perimeters, and at the time of this study, I thought they were really big fires, and I don't totally think that anymore, and we'll come back to that. But for what it was, these were 5 fires, 5 different ecosystems, a lot of beavers in there. I wanted to see, are they able to create these green patches consistently, repeatably, reliably, over and over and over again, or was it just something where we got lucky in Idaho? To do that, I want you to imagine that you go out into every single stream in my study areas. From a designated starting point to a designated stopping point, you're going to walk along the creeks. And as you walk, you stay as close to the river as you can, and you take notes. How green is the vegetation here? Is it alive, is it thriving, or is it dead and burnt? You're also taking notes on if there's beavers there. Can you see their dams? Can you see their canals, their lodges, their ponds? And you do this on every single stream in all of those fire perimeters, and you do this the year before the fire, so before any sort of significant disturbance has happened. And then you do it really right when the fire is happening, so as that fire is active in this landscape. And then you do it again the year afterwards to see how things recovered. And so I did this, except instead of going back in time and time traveling and walking along all these creeks during wildfires, which is dangerous, I used satellites. And instead of taking notes by hand, I was extracting what are called pixels along the entire stream profile to see how green was this vegetation staying. And what I'm showing you here is NDVI, or Normalized Difference Vegetation Index, which is basically just a measure of how green the plants are. A lower number indicates they are less green, a higher number indicates they are more green. Along the x-axis on the bottom of the graph, that's the distance you've walked along the creek from your starting point to your stopping point. And then marked with little black boxes is where you saw beaver dams. Now this dashed yellow line on there at point 3, that's a threshold. And a healthy riparian zone during the growing season should be above that threshold. If it's not, something is disturbing those plants. And in this case, I'm expecting that disturbance to be fire because I'm intentionally studying wildfires. Now those green curves, that's the year before the fire and after the fire. So this is bookending the disturbance. And then that brownish curve, that is the year of the fire. And you can see for the first bit, all 3 curves look kind of the same. So you're walking along the creek and it's green every year and you're like, all right, nothing's changing, this isn't a big deal. But then right around 1,500 meters along the creek, that changes. And suddenly, during the fire, you stop seeing greenness and everything's below that threshold. You're seeing burnt vegetation. And the timing of that change lines up pretty much perfectly with when you leave the beaver complexes. And to make that difference for you even more clear, I've taken the difference for you and plotted it, and so now a higher number indicates you are more affected by wildfire, you are seeing more burning, and a lower number indicates you are less affected by wildfire. The black boxes are still the beaver dams, and it becomes even more apparent from this plot that the beavers are effectively suppressing the wildfire. They are keeping it green and stopping it from burning, and as soon as you leave those beaver complexes, it is a completely different story. And I saw this everywhere. This wasn't just on one creek. This wasn't just one of my plots. They all looked like this. This was consistent. This was repeatable. This was reliable. And overall, the numbers that came out of this was that the beaver-dammed areas were burning 3 times less than the areas that did not have beavers. So there's a huge factor of protection that they are offering just by going about their beaver lives. They're not out there trying to be wildfire fighters. They are just trying to be beavers. But in doing what they do, in building their dams and digging their canals and changing the landscape, they're building an enormous amount of fire resiliency. And I really like this picture that I got after I completed the study actually and was talking about it with someone. They happened to be on a helicopter doing the post-fire surveys in one of my study areas, and they were like, oh yeah, we were flying this back in 2000, and it was so fascinating. We kept seeing all these green patches that we flew over to take these pictures. Do you want to see them? And he sends me these, and it's beaver dams. They were in their helicopter looking at the beaver dams being like, wow, this is so green, amazing. Not the story on that creek next to it though that did not have beavers. It is burnt all the way to the river bottom. So I'm like, great, it's done. I'm gonna finish my talk a million years early, right? Wrong, this is not done. This just opened the door. And I was so excited about this study, and I was convinced like beavers have solved climate change and wildfires, and it's amazing. And then the last few years have happened. And the wildfires I was looking at, I don't really think they're big wildfires anymore. I don't think that's even the kind of wildfire we see very often anymore, because we're in the age of megafires, and we are seeing fires that are breaking the rules of how fires are supposed to behave. And now megafire, that's a fire with a burn area larger than 100,000 acres. And just being a big fire doesn't make a fire bad. And I want to emphasize again that there is a lot of good fire, and that the Western United States especially needs fire in a lot of its ecosystems. But these megafires, a lot of times they got to be that size because they're exhibiting some really extreme and self-sustaining behaviors. They create pyrocumulus clouds, which are ember and ash spewing clouds. So they are literally making their own weather systems, spitting down fire instead of rain, and then that starts more fires that merge with the first fire, make that original fire bigger, which lets it make bigger weather systems. And so then it starts to make pyrocumulonimbus clouds, which are sometimes called the fire-breathing dragons of clouds. And that's because these are the types of weather systems that wildfire creates, where you see those viral videos of fire tornadoes and fire storms, where it's like a blizzard, but instead of snow, it's fire. And that's a problem because that kind of weather that they create and the way that they can sort of amp themselves up into bigger and bigger fires leads to really explosive spread rates, like 100,000 acres in a day. And that's too fast for us to fight. That's too fast for people to evacuate from. That's just too fast. And when they spread that fast, they leave these huge swaths of moderate and severe burning in their wake. And that's not good fire. Those big, huge patches of homogeneous, high-severity burning, that's what destroys ecosystems. That's what takes decades to recover from. And that's absolutely not something that belongs in the floodplain or in the riparian zone. And so thinking about these megafires, I really wanted to know, okay, well, beavers can handle wildfires, but what about megafires? What about these really extreme systems? Is this rodent and its pond going to be able to stay healthy and happy and keep that green patch green even during these events? Luckily or unluckily, depending on if you're thinking about it from the context of our future or my research, there were some really big fires in 2020 in the Rocky Mountains. And this was kind of unique because megafires for a long time have kind of felt like a California problem. Like we have a lot of them and they're bad every year, but at least it's just California. Except it's not anymore because they're moving further and further east. I'm pretty sure right now we have megafires building or currently existing in Arizona and New Mexico. A lot of us may have flown over their smoke yesterday. It was covering about half the United States. And so these fires are creeping further and further east, and they're burning places that have not had fire in a long time, which helps them be even more extreme. So I looked at 3 of these fires that were burning on essentially landscapes that hadn't seen megafire in about 100 years. And they were all pretty big, 200,000-ish acres, and they all had a lot of beavers within them. This is in Colorado and Wyoming primarily. And the plots that I'm showing you up here, this is dNBR, which is a measure of burn severity. And just looking at this, red is high severity, and even on perhaps not the best projector in the world, we can see that there is a lot of red in these fire scars. And so I wanted to use dNBR to think about, okay, how much burn severity difference is there between these beaver ponds and these beaver dammed areas versus the rest of the landscape in these 3 megafires that were honestly pretty ridiculously extreme. So just a little quick note on dNBR for the nerds in the audience, like me. What is this and what is it telling us? If you don't want to listen to this part, that's fine. Just look at the text at the bottom. High dNBR means that it is more burnt, so we have higher burn severity. If you are a nerd that likes this kind of stuff, dNBR is a spectral index that lets me know how much severity has occurred in a given pixel during a wildfire event, and it's exploiting the differences in how burnt vegetation and unburnt vegetation reflect light back up at the satellites, which you can summarize by saying, if it's more burnt, it's going to have a higher dNBR. But why do we even need this, right? We can look at a landscape, we can see the beaver dams there, we can see that they don't burn over and over and over again. It's not even shocking anymore. When I see these images come up in my research, I'm like, oh yeah, it didn't burn. What else is new? Like that happens. What dNBR and what burn severity really offer and add to this picture is that they let us quantify it. So we can actually measure how much less burning to a number is occurring in these beaver complexes versus these undammed areas. And we can break up any landscape into thousands and thousands of little pixels and little bitty areas, and we can see in every single one how burnt was that little patch. And then we can aggregate them and we can put them together and say, okay, all the little patches in the beaver dammed areas, how burnt were they? All the little patches outside of that, how burnt were they? We can look at the fires as a whole and see how much burning, how severe were these fires? And all of these fires were pretty severe. The Cameron Peak Fire, the East Troublesome Fire, the Mullen Fire, all of them had a lot of pixels that were falling into the moderate and severe burning categories. So these were not casual wildfires. These were not trivial wildfires. These were pretty destructive wildfires. And these thresholds that they're crossing, I've labeled for you on the plot. So anything above one of those lines indicates that all the data above that point falls into that category. So everything above that kind of salmon-colored line, that is the moderate to high severity burning. But not everything burned the same within these fire areas. The burning and the burning intensity was the highest outside of the river network. So if we're just looking at the hill slopes, we're looking at things that are not connected to the aquatic system, we saw really high burning. In every single fire, a large amount of the data was falling into the high and the moderate severity categories, which wasn't that surprising because we could see that. We could see it on ground, we could see it from photographs, we could see it just looking at the data. But really there was a lot of red, and the red here indicates that there was a lot of this severe burning. It was also pretty severe burning within the river network when we were outside of the beaver complexes, which is a little more disappointing because our rivers are supposed to be wet and they are supposed to be pretty fire resilient and fire resistant. And in this case, they were not. They were burning pretty significantly throughout all 3 fires. And again, we saw a lot of those patches of the landscape falling into the moderate and high severity burning categories, so they were not able to resist the wildfires. But the beaver dammed area was very different. It was very low. In fact, almost all of the data was falling into the low burn or the completely unburned categories. It was a significant departure from what we saw outside of the river network and what we saw in the river network, but away from the beaver ponds. And this was a completely different response. When you look at all 3 of them together, it becomes pretty obvious one of these things is not like the others. One of these areas is not burning during wildfire, and the other 2 are. And the area that is not burning during wildfire and the area that is not burning during megafire was again the beaver complexes. And that difference that we saw, that was significant. both in the statistical sense that they were legitimately different values, but also in the sense that it was a big difference. This was significant. In both the hill slopes and in the river network without beavers, a lot of the landscape was in the high and moderate severity burn categories. It shouldn't be that much. A healthy fire, a good fire, has a lot of low, a medium amount of middle burning, and just a couple little smidgens of severe in there. We should not be seeing 41% high burn severity outside of the river network. That is too much. But in the beaver dammed areas, it was a lot better because 89% of the landscape was either low burned or no burned. 89% of the landscape was resisting the fire or experiencing good fire. And that's a really big difference. That's what we want to see because that's preserving the habitat and the ecosystem, and that's preserving the aquatic connectivity. And we can confirm this. We don't have to rely on just one type of data. We can use false color mapping, which is a way of assembling bands of light differently than how our eyes see. And this is actually a great time to have a not great projector because you can't tell where the fire is in this image, and this is true color. So when we look at satellite images with our eyes, if I'm trying to see what burned and what didn't burn, my eyes cannot distinguish that. I even can't distinguish it on this computer where it's a better resolution because burnt landscape looks a lot like trees. It's kind of dark brownish, greenish, gray. But with false color, we can assemble that light differently so that even on a not great projector, you can still tell what's burned. There's this black area that's been burnt and then these red areas around it that are unburnt. You can assemble it in even more ways. So maybe you want to see the hot spots. You want to see where the fire actually is. You can play with these different types of light so that it's really clear for you to see with your own eyes what areas burned, what areas didn't burn, and to use that as confirmation of what you see in the burn severity data. And for the more traditional people amongst us, you can also go out to the field after you've done this sort of satellite analysis to see with your own eyes if what you're seeing is true. And so I did that. I went out to these burn scars and looked around within the beaver ponds. And honestly, if I kept my eyes down away from the hill slopes, I would not be able to tell that this area had been in a severe wildfire. There was healthy vegetation everywhere. There were pine trees with needles. There were willows that were fully fleshed out with their leaves. There wasn't a smidgen of burning anywhere I could see. There's this little otter hanging out on the beaver dam and on the beaver lodge, and everything seems like it's just chugging along a healthy ecosystem. But then you do look outside of the beaver complex, and you do look up at the hill slopes, and you do look in the river network where there weren't any beavers, and it's a completely different story. This area definitely experienced a severe fire. All of the trees were burnt down to these little stumps and toothpicks. Every single bit of vegetation on those hill slopes is dead. And that is a huge risk for landsliding and for mudsliding afterwards. We can't have these huge swaths of severe burning for so many different reasons, but we do. That's what we have on the hill slopes right now, and that's what we have in the river network where we don't have those beavers. And granted, we can't necessarily fix the hill slopes with beavers, but we can fix the river network, and that's where I think we need to be really focusing our efforts on, is fixing what we can and hoping for the best with what we cannot. And what I really liked seeing out in the field was that looking across the landscape, I could actually see the burn severity transition from Refugia, from this completely unburnt sort of patch, into a high burn severity. And so over by the beaver complex, we have that three-story of vegetation. We have the pine trees, we have the willows, and we have the grasses. And everything is doing fine. Everything's fully leafed out. Now, the grasses are not a good indication of burn severity because they pop back right after the fire. But the willows and the pine trees are, because they cannot recover that quickly. And as we move away from the beaver complex, what you can start to see is changes in the willows and changes in the pine trees. First we lose the willows, they're burnt, and the pine trees are kind of hanging on. And then you go further away and the willows are gone and the pine trees look kind of burnt, and you keep going further away. The pine trees don't even have their needles anymore. They're totally burnt. And you keep going further away, and suddenly there's no tall standing vegetation. And that's where we get into that severe burning. And that's how we can see that transition on ground that we also saw in the burn severity, that we also saw in the false color mapping of how these beaver complexes can take a wildfire that's burning at high severity and in a relatively short distance, take it down to absolutely no burning. And I really want to emphasize that this is not an anomaly. This is not something that we just saw once. We saw this back in California before anyone was really studying this, and it was so fascinating that people on the burned area emergency response team detoured their helicopter flight to take photos of this because they were like, wow, what is going on here to keep this system healthy? We've seen this up in Canada. We've seen this in 1.5 million acre fires, which gives me some hope about our megafires, although I hope we don't keep cracking that million acre mark. We've seen this in Idaho. We've seen this in Colorado. We just saw this in Oregon last year, and I thought this one was particularly interesting because up in the Bootleg Fire in Oregon, the landscape is a lot flatter than what I'd been looking at in the Rocky Mountains. And there was some thought that I had like, okay, well maybe it's just the fact that we're in the valley bottoms and that's sort of this natural bowl for water. And so it's staying a lot wetter there because it's a valley bottom, but we won't see this in a flatter landscape. But then we absolutely did see this in a flatter landscape. This patch is still just as green and just as unburnt, and it doesn't have the benefit of these huge canyon walls sort of shadowing it from the wildfire. It's not the end of the story, though. There's more questions, there's more work to be done. We can say pretty confidently that, at least for now, beavers are still able to maintain and create these patches of refugia even during megafires. They can do it during normal wildfires. I don't know if we're gonna have a lot of those, but they can still do it during megafires, which is good for now. These fire refugia patches, there's a lot we don't understand about them. We've seen different animals make use of them. We've personally seen otters and bobcats and bears use these post-fire and possibly during fire to seek out refuge, but we don't know who else can use it and for how long and when and where this is possible. We don't know if in wildland firefighting these are big enough, reliable enough patches that we could put firefighting equipment there and be confident that it will not be affected by the wildfire. We also want to know how these are going to function post-fire, because it isn't just trivial to have this huge patch of fully mature landscape sitting in the field unburnt. This is something that can potentially reseed the rest of the landscape faster and encourage quicker, stronger ecological recovery. This is potentially something that can act like a great big Brita filter and catch all of that sediment and ash that is coming off of these really burnt hill slopes and keep it out of the river network. Don't let it coat all of the fish's gills and suffocate them. Sink it out into sediments and bury it. Take advantage of that natural high sedimentation rate in these beaver ponds to help us post-fire with some of that debris that moves through the rivers. So there's a lot more work to be done. I'm very hopeful with what has been done, but hopefully some people in this room can push it a little bit further so we can really understand the true potential of these patches of refugia. I want to give a quick shout out to some of my students who've worked on all of this research with me. I do not work alone, and we've had lots of funding from all sorts of different funders, up from like National Science Foundation down to actually a local restaurant was feeling very inspired and gave us a research grant because they wanted beavers back too. So thank you all for listening, and I think I have a few minutes for questions, and if we don't get to your question, you can always email me or find me on Twitter. It's a non-stop stream of beavers. So thank you.
What happens to the beaver population after a mega fire? Do they have enough of a food resource to survive?
That's a great question. So it totally depends on the site. In one of the fires that I looked at, the beavers were in pretty isolated pockets, and they were still there and alive post-fire, but the area that they had to work with was pretty small. And so I would not be surprised if those beavers had to move on from that site afterwards, because they can only survive so long when they only have a handful of acres of food left for them. But in places that had more robust beaver damming and where the beavers were occupying larger stretches of the river network, they stick around because they have acres and acres and acres, hundreds of acres of habitat still available to them. They have more secondary dams creating more of this buffer around them. And from what I've seen, they're fine. I think that if you have too much sediment that comes in afterwards, that can also encourage them to leave because they can't dig it out fast enough. But with anything beaver related, like the more we have, the better the response is gonna be. So if it's a fully dammed watershed, they'll be totally fine. If it's just a little beaver dam here and there, they might need some help making it past that initial post-fire period.
I have a question and a comment. The first question is, did you find any places where the beaver complexes actually acted as sort of a fire break, where they were able to stop fire from going up, say, on an adjacent hill slope, or was it just too all-consuming to really prevent that kind of thing?
So I've seen that just once, and it was in Colorado, and it was a beaver complex that was over 1 kilometer wide. So it was absolutely massive. I call it Damageddon because it's like so many beaver dams. But I will say that my research is biased towards the most destructive extreme events. Like I'm intentionally selecting wildfires that I think are going to be able to blast through beaver ponds. And when I see them even create patches, that's impressive. I think if I was looking at more low-intensity fires and more grassland and shrubland wildfires, it'd be more likely for me to see true fire-breaking behavior. When we have these big pine forest fires, it's up in the crown of the trees and a strong wind will blow it right over, and that's what we tend to see.
And then comment is, in those sort of low gradient systems like you described in Oregon, I wonder if you're seeing maybe a transition of vegetative destruction where you might have that sort of groundwater influence actually working its way back up into the sort of quasi-upland landscape and providing sort of a buffer beyond even maybe the riparian area, or if that's something you've looked at.
It's definitely something I've thought about, and just with observations and not quantified yet, the patches that I saw in Bootleg are a lot broader per beaver dam than the patches that I see in the mountains, because like you said, they can't have as wide of a groundwater effect when they're on the steeper slopes.
Excellent job, Emily.
Thanks, Alexa.
Yeah. I'm always so impressed with your research, and I've seen this talk probably 5 times, and every time it's more expansive, more informative, faster, just to keep it all in. And I just want to thank you, for one, for the incredible work you're doing to push the relationship, the acknowledgement of the relationship between beavers and fire and the positive benefits. I do want to say that Emily has been inspiring to me, and I study beavers restoring streams after wildfire and debris flows. And to answer this gentleman's question anecdotally about beavers acting as fire breaks, yes, we have seen it numerous times in the Methow Valley on small scale fires, smaller scale fires, or at least periods of low severity burning. But we've also seen firefighters, the humankind, backburning from beaver ponds. And that's one of those management focuses that we could spread across the West to say, when you're dealing with that kind of mega fire, where do you start from? Where do you put your fire break lines, your intentional fire break lines in? So I think it's a whole realm of investigation that Emily's leading powerfully, and that we can all contribute to anecdotally or even jumping on research projects in conjunction with Emily. She's really incredible to work with. So.
Hi, so you touched a little bit about how beavers are resilient to fires post-fire. Are any scientists looking into using remote sensing to identify areas that would be good stepping stones or wetlands to create dams so that they can hop, skip, and jump to those areas and then prevent wildfires from occurring?
Yes and no. I've definitely thought about it. But it's definitely something we need a lot more work on, especially thinking about all of the work I've been doing. It's really from the disaster already happened, so let's see, if it worked or not. And I think there's a lot to be said for looking at systems where we have beaver, or where we want beaver, or where we want to do beaver mimicry, and thinking, okay, this is definitely fire prone, it's high fire risk, we're doing all sorts of other fire management things. How can we actually utilize the knowledge that we gain from this post-fire data to prepare a landscape so that if and when a fire does start, it's not going to be able to ever sort of ramp itself up into these really extreme states, because it just hits speed bump after speed bump of restored river. And there's huge potential for that. There's a lot more work that needs to be done researching it, and then just getting those results out to the people that actually do fire management. One of the biggest hurdles in this kind of research is getting information from sort of the academic sphere out into the people that are actually making the decisions and doing the work. So definitely something that needs more attention, but I agree is really important. Thank you.